Why should you keep your distance from large trucks? It's not that they intend to hit you, it's that they often can't see you. This is due to the blind spots of a large truck, which are areas the driver cannot directly see through the rearview mirror or windows. Generally, the larger the vehicle, the larger the blind spots, which exist at the front, back, and both sides of the truck. The right side blind spot is particularly large and dangerous. When you inadvertently enter a large truck's blind spot, you're in a zone of hidden danger. The truck driver, unable to see you, may accidentally collide with or run over your vehicle. Such accidents are all too common. Therefore, if you find yourself in a large truck's blind spot while parking, move out of the driver's visual range as soon as possible. When driving at high speeds, avoid staying alongside a large truck in its blind spot for an extended period. If you wish to overtake a large truck, do so quickly. Do not linger in the blind spot behind the truck. Maintain a safe distance and always watch for the truck's signal lights. If you find yourself sandwiched between two large trucks, change lanes promptly. Otherwise, you risk being unseen by the front truck and unable to react if the rear truck cannot brake in time. Moreover, when a large truck turns, there is a difference in the path of the inner wheels. The rear wheels do not follow the same track as the front wheels, and this discrepancy increases with the wheelbase. This area also falls within the driver's blind spot. If you accidentally enter this hazardous zone, you could be rolled under the vehicle without the driver's knowledge. If you can't remember all these points, just remember one key thing. It's always safer to keep a distance from large trucks. Like and follow for more informative 3D videos. Is the engine the heart of the car? I believe the engine is more like the stomach of the car. The human stomach converts food into energy and stores it in the body. Similarly, a car engine converts fuel into mechanical energy. The larger the displacement, the higher the fuel consumption, and consequently, more mechanical energy can be converted. Let's explore how the engine converts fuel into mechanical energy. The car engine relies on fuel combustion within the cylinder. The heat generated drives the piston up and down, smoothly converting it into mechanical energy. The piston completes a 4-stroke cycle with 2 up and down movements: intake, compression, power, and exhaust. The first stroke is intake. The intake valve opens, the exhaust valve closes, and as the piston moves downward, vacuum pressure draws air and fuel into the cylinder. The computer's ECU controls the air-to-fuel ratio, which is ideally 14.7 to 1 for complete fuel combustion. This ratio results in higher power conversion rates and minimal exhaust emissions, 14.7 kilograms of air to 1 kilogram of fuel. The second stroke is compression. Both valves are closed as the piston moves upward, compressing the air-fuel mixture for thorough mixing. Gasoline engines typically have a compression ratio between 9:1 and 12:1, while diesel engines range from 12:1 to 22:1. Higher compression ratios result in greater density of fuel and air, producing more thrust upon combustion and thus stronger power. The third stroke generates power as the piston reaches its top position, known as top dead center. A spark plug ignites in gasoline engines, similar to a lighter igniting a compressed fuel mixture. The ignition forces the piston downward, converting fuel into mechanical energy. Diesel engines compress and ignite without spark plugs due to diesel's properties. High temperature and pressure cause spontaneous ignition. The fourth stroke is exhaust. With the intake valve closed and exhaust valve open, upward-moving pistons expel burned gases from the cylinder. This completes one 4-stroke cycle, with the next downward piston movement beginning intake again. During high-speed driving, this cycle occurs rapidly. At 3,000 revolutions per minute, an engine averages 25 4-stroke cycles per second, with each piston moving up and down 100 times, a frequency that would be quite intense for a massage. 90% of people don't know that the function of the shock absorber is not to absorb shocks, but to limit the spring from bouncing after it absorbs a shock. When the car is driving, the impact force from the wheels bouncing will be fed back to the car body, and the spring in the suspension system is the main device to absorb this vibration. When the car goes over bumps, the impact force causes the spring to compress. After absorbing this force, the spring will bounce repeatedly, which can make passengers feel as if they are riding in a boat on rough seas. Those who have been on a boat can explain this sensation to those who haven't. The feeling of being on a boat is quite distinct from motion sickness, and it's hard to describe in words. To avoid this repeated bouncing of the spring, we need to dampen the spring's rebound, accelerate the attenuation of spring vibrations. There is a device called a shock absorber. Inside the shock absorber is a piston surrounded by hydraulic oil. Normally, it cannot be compressed because there is a small hole in the piston. When pressed down, oil below flows to the top through this small hole. Because it's tiny, the piston descends slowly. Then, during the return process, an external spring pulls the piston upwards, and oil above flows back down. The small hole limits flow rate, ensuring that rebound speed isn't too fast and effectively reducing repeated bounces of the spring. This is the basic principle of shock absorption. Whether it's air suspension or adjustable resistance suspension, they are based on this principle with additional devices added. The size of this small hole in the piston determines how fast the piston rod moves. The speed of piston movement determines whether the impact felt during bumps is soft or hard. So now you understand the basic principle of shock absorbers, right? Where does brake boost come from? Why is the brake pedal so hard before the car starts? And why can you only step on it after it starts? The secret behind all this lies in the vacuum booster pump. Let's take a minute to learn more about the working principle of the brake vacuum booster pump. Imagine a sealed bottle with a vacuum tube inserted. If you remove the air inside, the bottle will deform instantly. This happens because after creating a vacuum, the air pressure inside the bottle becomes inconsistent with the external air pressure. The external air squeezes into the internal vacuum, causing the bottle to deform. The vacuum booster pump operates on this principle. It has a sealed outer shell with only one vacuum pipe joint. When connected to a vacuum pipe with a one-way valve, and after the engine starts, it extracts air from the booster through this pipe, forming a vacuum inside. Inside the vacuum booster pump are two chambers separated by a diaphragm, but they are connected by a channel. So when the engine starts and without braking, both chambers are in a vacuum state. When the driver steps on the brake pedal, the channel between the two chambers closes and air enters the left chamber. Since the right chamber remains in a vacuum state, pressure builds up in the left chamber. This pressure pushes the diaphragm to the right, and the force from stepping on the brake pedal combines with this vacuum pressure to create a boost. When the driver releases the pedal, a valve piston prevents air from entering the left chamber, and channels between both chambers reopen. The air inside is then evacuated by the vacuum tube, restoring both chambers to a vacuum state. If the vehicle is not started, both chambers of the vacuum booster pump contain air and lack vacuum pressure to assist in pressing the diaphragm. Therefore, it feels very hard to press. Essentially, there is no power assist at this time. Why do highways charge tolls? The answer lies in the substantial cost of road construction. Consider this. If you build a highway on a steep hillside, drivers will inevitably encounter blind spots while navigating it. Whether driving uphill or downhill, the situation becomes extremely perilous. To mitigate this risk, excavation is necessary before constructing the road. By doing so, we ensure that drivers have a wider field of vision. Additionally, the design of highway curves is crucial. When a car turns, it follows a circular motion, requiring centripetal force for smooth navigation. Without this force, even experienced drivers can make mistakes. Consequently, the outer edge of the highway should be slightly raised. To enhance durability, the road surface is divided into several layers. Otherwise, cracks and water seepage could occur, leading to soil erosion and potential highway failure. During construction, lime soil and gravel are laid on the earth mover. Furthermore, an advanced drainage system is essential to prevent water accumulation during rainy days. These complex projects contribute to the high cost of each kilometer of highway, often reaching tens of millions. Bridge highways incur even greater expenses, necessitating additional steel bars. Bridge decks are typically assembled in sections, but concrete's expansion and contraction properties pose challenges. To address this, expansion joints are strategically placed to allow for automatic adjustments under extreme temperatures. I have always been curious about how turning the steering wheel can turn the car. The principle is quite simple. and the key lies in the steering rack. When the steering wheel is turned, the steering shaft transfers this force to the steering rack, and the motion tie rod of the steering rack is displaced, thereby driving the steering arm to move and ultimately enabling the steering of the wheels. However, this structure makes the steering wheel very heavy to operate, so cars are equipped with power steering systems to make steering easier. It uses a brushless DC motor to drive the steering sensor, which senses the force and direction of our steering wheel turning in real time, and then transmits the information to the electronic control unit. This unit then controls the electric power, allowing us to easily turn the steering wheel. Nevertheless, when the car is turning, the turning degree of the left and right front wheels is usually different. If you observe carefully, you will find that the intersection of the left and right front wheels paths will always be located on the rear wheel line, which makes the car more stable when turning. However, if the car has a serious collision, it may cause the wheel's alignment to change, thus affecting normal driving. At this time, you may have to consider performing a four-wheel alignment. The person who invented the car engine was really a genius. The engine rotates very fast. The speed of a sports car can reach 10,000 RPM. Such high rotation requires lubrication. The lubricating oil is injected through the engine oil filling port and flows into the oil storage tank along the engine cylinder channel. The lubricating oil level can be observed through the oil gauge. It should be in the middle position between the upper and lower marks. When the car is started, the engine begins working, and the oil pump starts to draw lubricating oil from the oil storage tank. The lubricating oil first passes through the engine oil filter and the oil separator, which can trap the debris in the oil filter and prevent it from entering and damaging the engine. Then the clean lubricating oil flows into the connecting rod through the pipe. An oil film will form on parts such as crankshafts and bearings that are in contact with each other. Lubrication can effectively prevent wear of these parts and absorb the heat generated by the high-speed rotation of the engine. The oil also picks up dirt and fine debris along the way and is cooled by a fan before returning to the reservoir. This process only takes a few seconds. This is how lubricating oil protects the car engine through continuous circulation. The inventor of the turbocharger was a genius, creating a device that makes you feel pushed back when driving. A turbocharger is essentially a compressor, though its function is far from simple. Take note, the turbocharger is typically positioned between the intake duct and the air filter. It comprises numerous parts. One side is referred to as the cold side, and the opposite side as the hot side. The internal shaft has two ends, the turbine and the compressor. The turbine connects to the engine's exhaust port. The continuous flow of exhaust gas can drive the turbine to rotate, reaching speeds up to 150,000 revolutions per minute. The high-speed rotation of the turbine shaft generates heat, hence grooves are incorporated into the central housing for coolant to flow through. Sealing rings are installed on both ends of the shaft to prevent coolant from mixing with the turbine exhaust gas. Once the turbine is driven to rotate, the exhaust gas is expelled. As the turbine spins, it also activates the compressor, drawing air in from the cold side and pushing it into the intake duct after compression. However, the temperature of the compressed air is excessively high, posing a risk of explosion if it enters the engine directly. Therefore, it must undergo an intercooling period to cool down before entering the engine. Following this sequence of operations, you can start the car by simply stepping on the accelerator. The clutch in a manual transmission car is a genius design. It serves as a separation and engagement system, allowing you to cut off or transmit the power output from the engine. This functionality relies on the concept of friction. Here's how it works internally. 1. Flywheel disc. The flywheel disc is connected to the engine's power system. It acts as the power input disc and becomes the driving key for the friction clutch. 2. Clutch plate. Connected to the output shaft, the clutch plate serves as the output power disc. It receives power from the engine and transmits it to the transmission. 3. Pressure plate and diaphragm. Spring. These components are responsible for clamping and separating the clutch plate and the flywheel disc. When the center of the spring is pressed, the outer edge moves in the opposite direction. When you press the clutch pedal, the clutch lever pushes forward. The release bearing compresses the center of the diaphragm spring, generating pressure. This separates the clutch disc from the flywheel disc, preventing power transmission to the transmission. Releasing the clutch pedal, the clutch plate and flywheel disc combine. Friction between them allows the flywheel disc to drive the clutch plate, transmitting engine power to the transmission. In simple terms, pressing the clutch cuts off power output. Releasing the clutch connects the engine's transmission to the gearbox, transmitting power to the wheels and allowing the car to move. Now, why should you press the clutch quickly and release it slowly? The reason lies in smooth gear changes. Quick clutch engagement prevents excessive wear, while gradual release ensures a seamless transition between gears. It's all about maintaining balance and prolonging the clutch's lifespan. How to choose between MT, AT, CVT, and DCT gearboxes. A video will give you a comprehensive understanding. First of all, Montana is a traditional manual gearbox. It requires the driver to frequently manually operate to increase or decrease gears while the vehicle is driving. So the disadvantages of an MT gearbox are not only that frequent gear shifting is troublesome, but also that the operation is complicated, and there are certain requirements for the driver's skills. The advantage is good durability, a low failure rate, and including the later maintenance cost is not high. Then there's the AT automatic gearbox, which is currently considered the most perfect gearbox by most car owners, because it is not only mature in technology, but its advantages also include strong reliability and the ability to withstand large torque. The disadvantage is that it has relatively high fuel consumption and later maintenance costs are also high. Next is the CVT continuously variable transmission. The biggest advantage of CVT is smooth gear shifting and low fuel consumption, making it very suitable for home use. The most common CVTs on the market are generally divided into steel belt type and steel chain type. Among them, steel chain CVT is better than steel belt type because it can withstand greater torque, is less likely to slip than the steel belt type, and is also more efficient. The disadvantage is slow acceleration response, and it cannot withstand too high torque. Finally, DCT dual clutch transmission's biggest advantage is fast shifting speed and high transmission efficiency. Dual clutches are generally divided into dry and wet types. Among them, the wet dual clutch is more durable than the dry type because the dry dual clutch is more prone to overheating. However, in terms of shifting speed, the wet type is not as fast as the dry dual clutch. As for how to choose, it depends on your needs. The person who invented the engine is truly a genius. Can you imagine? The largest engine in the world stands 13.5 meters high, equivalent to the height of a 4-story building, and can output 108 920 horsepower at 102 RPM. In this issue, let's discuss some of the most powerful engines in the world. If you have seen a Caterpillar 797 large mine truck in real life, you know it is as tall as a 2.5-story house. To power such a beast, an ordinary engine will not suffice. The Caterpillar C7520 engine was created for this very purpose. It produces up to 5,130 HP, is 2.3 meters wide, 6.6 meters long, weighs over 23,400 kilograms, and uses 105.8 liters. This 4-stroke engine is water-cooled and diesel-powered. It is also used to generate electricity, capable of producing up to 4 megawatts, enough to power 350 average homes. Yet this is just the 5th engine we are talking about in this issue. Modern electric trains are impressively fast, surpassing their predecessors. Diesel and steam engines were always the norm. The 4014 train, named Big Boy, is still operational today. The engine is 40 meters long and weighs more than 508,000 kilograms, equivalent to the weight of 4 Statues of Liberty. It requires more than 25,400 kilograms of coal and 94,600 liters of water to fuel the engine. Despite its massive size, it can reach speeds of 112.6 kilometers per hour. However, compared to the GE9X, the world's largest and most powerful commercial jet engine, it pales in comparison. Manufactured by General Electric Aviation and developed specifically for Boeing's wide-body jet aircraft. The front fan's diameter measures 3.5 meters, and the entire engine is as wide as a Boeing 737 fuselage. The fan blades can generate 100,000 pounds of thrust, nearly as powerful as the Saturn rocket that first took humans into orbit. Although this engine is enormous, it is surprisingly light because it is 3D printed with carbon fiber composite materials. The world's largest wind turbine, manufactured by China's Mingyang Smart Energy Company, can harness the energy of strong winds on the windiest seas. Its overall height is 264 meters, and each blade is 118 meters long, longer than an Airbus A380. The blades span 242 meters in diameter and can cover an area greater than 6 football fields. The IC-16 can generate 80,000 megawatts of electricity, sufficient to power more than 20,000 homes. The Rocketdyne F1 is the largest and most powerful single-nozzle liquid-fueled rocket engine ever built. Constructed in 1957, a cluster of 5 F1 engines propelled the Saturn V rocket to the moon. This colossus stands 5.7 meters tall, 3.6 meters wide, weighs 8,400 kilograms, and can generate 1.5 million pounds of thrust. It does not consume conventional oil, but a mixture of liquid oxygen and RP-1 fuel. Even today, nearly 70 years later, the design of the F1 remains unmatched. However, it is worth mentioning that the rocket engine independently developed by China has the largest thrust in the world. The engine has a diameter of 3.5 meters, a maximum thrust of 500 tons, and is powered by high-energy propellants. In the near future, we will also see it in space. Now, let's take a look at what the world's largest engine looks like. It is the Wärtsilä RT Flex 96C, manufactured by the Finnish company Wärtsilä. It is designed to provide efficient power for large container ships carrying more than 16,000 containers. It weighs 2,300 tons, is 27 meters long, and stands 13.5 meters high, equivalent to a 4-story building. It also has its own team of engineers who can perform repairs anytime, anywhere. A single crankshaft in the engine weighs 300 tons, and each piston weighs 5.4 tons. It has 14 cylinders and is turbocharged. It is powered by a 2-stroke diesel engine and is the most powerful in the world. It can output 108,120 horsepower at 102 RPM and can propel a container ship at a speed of 27 knots. The person who invented the engine is really smart. This issue, known as the speed bump for boys, will give you a detailed understanding of the working principle of a gasoline engine. If you happen to have a car, you can take the engine apart and examine it based on the video. This is our common piston engine, which can be arranged in a variety of configurations, including inline, opposed, V-type, or flat. The more cylinders you have, the more power you can output, which also increases fuel consumption. Here is the detailed structure inside the engine. First, the intake valve opens, the piston moves downward, and the mixture of air and gasoline flows into the cylinder. This is the intake process. The intake valve then closes, preventing further inhalation of fuel and causing the mixture to be compressed at high temperatures, which is called compression. An explosion occurs when a spark plug ignites the compressed mixture of gases, and the force from the explosion drives the piston downward, which is called a power stroke. Then the exhaust valve opens and the piston rises to expel the exhaust gas. This process is called the exhaust stroke. Simply put, gasoline burns in this internal structure to generate heat energy. The special design of the crankshaft converts this energy into mechanical motion, which is finally transmitted to the wheels as continuous power. Coolant circulates around the cylinder to prevent overheating. The piston has 3 rings. The upper 2 are compression rings, which prevent flue gas and oil from flowing downward, and the lower one is an oil ring. Its function is to continuously apply oil to the inner wall of the cylinder, mainly for lubrication. Above it is the crankshaft, which converts the linear motion of the piston into rotational motion. According to the movement of the camshaft, the opening and closing of the valves are controlled through the crankshaft or a timing belt. Usually the durability of the belt is weaker, so chains are used more often, but they also generate more noise. There are two types of camshafts. One is called DOHC, which is also the type used in the above animation. There is also SOHC, which is characterized by using a single camshaft to control both the intake and exhaust valves. Inside the throttle body is a throttling method. When you step on the accelerator pedal, this valve opens, allowing a large amount of air to enter, which is then evenly distributed to each cylinder through the intake manifold. This is a linear four-cylinder engine, with four cylinders arranged in a straight line, also known as the L4 engine. As you can see from this simple model, the fuel enters the intake manifold and is divided according to the number of cylinders. But after the gasoline is burned in this engine and generates heat, the excess waste is discharged from the exhaust pipe. As the number of cylinders increases, the length of the engine becomes longer, and the body appears wider. However, many car brands now choose V6 engines. By arranging 6 cylinders in a V configuration, the length of the engine and the width of the car can be reduced, but the inline engine is quieter, and the power output will be smoother. This video briefly introduces the working principles of the piston engine. The person who invented the supercharger is really smart. The existence of the supercharger greatly improves the performance and power of the engine. So which one is better, supercharging or turbocharging? In this issue, we will use 3D anatomy technology to take a look at the working principles of these two superchargers. Please don't go away. Whether you want to buy a car or own a car, you can learn about it. First, let's take a look at how turbocharging works. You can see that the turbine is connected to the engine exhaust system, and the exhaust pipe is specially designed for turbine placement. The turbine has two separate compartments called the turbine section and the compressor section. When the heat and pressure drive the turbine or exhaust wheel, the exhaust gas flows through the turbine part. The upwind shaft exhaust wheel is connected to the compressor wheel. The compressor wheel sucks air through the air filter and the intake pipe. Its specially shaped blades force the air through smaller and smaller cavities and create a compression process. Air heats up during intake and compression, so most turbo setups have an intercooler between the turbine and engine intake to bring the air back to ambient temperature, since cooler air has a higher density. This helps force more air into the engine. Intercoolers work similarly to radiators. As outside air rushes through, the hot air passes through internal ducts to be cooled. At present, the common turbine types we have are the single turbo type, which flows all the exhaust gas into a single turbocharger, and the twin turbo type, which is generally used on V-shaped 6-cylinder engines. Let's take a look at how supercharging works. It is located at the top of the intake manifold. A belt transmits the crankshaft power to the supercharger pulley. A gear train transmits the input power to the opposite rotor. Outside, air enters the interlocking rotors through the air filter and intake duct, forcing the air through the supercharger's long fins spanning the length of the rotor shaft to break into lobes of air and through specially shaped exhaust ports at the bottom of the housing. The supercharger exhausts the air, which is the principle of mechanical supercharging. Let's introduce the different common types of superchargers, which are centrifugal superchargers and twin-screw superchargers. The design concepts have many similarities, but they are indeed mechanically driven. Centrifugal superchargers feature an exponential power curve adjustment that is fully boosted at the engine's redline, while twin-screw superchargers have a complex blade design that effectively compresses the air as it passes through the device. Everyone must have a certain understanding of mechanical supercharging and turbocharging. Simply put, supercharging is powered by mechanical energy through the crankshaft connected to the engine, while turbocharging is powered by the engine exhaust. The wasted heat energy in the air provides power. Superchargers have a positive displacement, can achieve immediate boost even at low speeds, and have a fairly linear power curve. Turbochargers create an exponential power curve. Because the turbine is powered by exhaust gases, it takes time to build turbine speed and pressure before usable boost is produced, a delay called turbo lag. Turbocharging is more effective than supercharging in high-power engines and also allows for better attempts at boosting. The rich play self-priming, the poor play turbine, and only madmen play surge. If it were you, what would you choose? The quality of a fuel car depends on its three major parts, just as new energy, pure electric cars also rely on three key components: the motor, battery, and electronic control. Mastering these three parts is essential to making an excellent pure electric car, which is why even internet companies now dare to venture into car manufacturing. A pure electric car cannot function without its motor, which generates a rotating magnetic field once powered on, causing the motor to rotate and convert electrical energy into mechanical energy. There are two common types of motors. Foreign manufacturers generally use AC motors like Tesla, while domestic car companies often use permanent magnet synchronous motors. The second major component is the battery. The power of the car comes from the battery pack, which is divided into 16 smaller modules. Each module contains hundreds of small batteries, amounting to thousands of small lithium batteries in the entire electric car's battery pack. These lithium batteries are not much different from the batteries we use in our daily lives. They are combined in series and parallel configurations. Inside the battery pack is also a cooling system. Coolant flows around the batteries to dissipate heat. The use of small batteries aims to achieve a uniform temperature distribution and better heat dissipation, ensuring each battery is cooled and extending the life of the battery pack. However, since the battery pack provides direct current and both synchronous and asynchronous motors use three-phase alternating current, an inverter is required to convert DC into AC. In this energy conversion process, an electronic control system is also necessary, equivalent to the ECU of a traditional fuel vehicle, allowing the vehicle's hardware and software to work together seamlessly. For example, the battery needs a battery management system to monitor voltage and current, while the motor requires a motor control system to manage DC to AC conversion. Electric vehicles do not need to switch gears like traditional fuel vehicles. Their acceleration and deceleration are controlled simply by changing the current's magnitude and frequency. Therefore, their transmission system is very straightforward, directly connected to the differential, and boasts a high response speed. Electric vehicles typically feature energy recovery systems. When going downhill or braking, the battery stops supplying power, and the motor acts as a generator using wheel inertia to generate electricity. This electricity is then stored back in the battery pack, achieving energy recovery. Because electric vehicles lack complex engines and transmission systems, their body costs are lower than those of traditional fuel vehicles. However, due to the high cost of battery packs, which account for about half of an electric vehicle's total cost, the overall price can be significant. If you had to choose again, would you opt for a traditional fuel vehicle or a new energy electric vehicle? Hydrogen-powered vehicles can achieve zero emissions, so why are they not widely promoted? Hydrogen-powered vehicles do not use hydrogen fuel engines, but rather hydrogen fuel cells. These vehicles are actually driven by motors, but unlike electric vehicles, they generate electricity through hydrogen fuel cells. The power system mainly includes hydrogen storage tanks, hydrogen fuel cells, and motors. Hydrogen fuel cells obtain hydrogen from the storage tanks and react chemically in the cell to generate current, which then flows into the motor to drive the car. The fuel cell is the core component, consisting of an electrolyte membrane in the middle and two plates. The left plate is called the anode and the right one is called the cathode. The hydrogen transported by the storage tank passes through the anode and is converted into electrons and protons by a catalyst. Protons can pass through the membrane, but electrons cannot. As a large number of electrons accumulate, if a wire connects the anode and cathode, the electrons will flow to the cathode through the wire. This flow generates current through the circuit, driving the motor to rotate. Meanwhile, protons react with oxygen at the cathode to form water, which is then discharged. However, the production and transportation of hydrogen are very demanding and costly, which is why hydrogen-powered vehicles have never been widely promoted. Some people say it is fuel-saving, while others say it is useless. Is automatic start-stop useful? What are its advantages and disadvantages? Do we usually turn it off or on? Before we understand this problem, we must first grasp the role and working principle of automatic start-stop. When we need to stop, the driver steps on the brake pedal and the vehicle slows down and comes to a halt. At this point, the car's sensor recognizes that the vehicle is stationary, and the wheel sensor confirms that the wheels are not turning. The sensor then relays the parking information to the computer's ECU. The ECU, based on the driver's brake behavior, interprets that the driver is parking and sends a shutdown signal to the engine. Simultaneously, the fuel supply system stops providing fuel. When the driver releases the brake pedal and presses the accelerator, the ECU detects the intention to drive away. It sends a signal to the starter motor to start the engine, while the battery powers up to energize the starter motor. Now let's discuss the advantages of automatic start-stop, which are quite clear: fuel savings. Additionally, it reduces emissions and contributes to environmental protection. When waiting at traffic lights, stopping for pedestrians, or encountering traffic congestion, the engine shuts off, eliminating fuel consumption and exhaust emissions. However, there are also notable disadvantages. First, frequent engine starts and stops put additional strain on batteries and starter motors. Consequently, automatic start-stop systems demand higher quality batteries, leading to increased costs. While an ordinary battery costs 300 to 400 yuan, a specialized battery for automatic start-stop can cost thousands of yuan. Despite their improved quality, these batteries still suffer greater wear due to frequent engine starts. Typically, an ordinary car battery lasts around 5 years, whereas an automatic start-stop battery lasts only 2 years. The same holds true for the starter motor, which has a shorter lifespan. After using automatic start-stop for 2 years, it remains uncertain whether the fuel savings offset the expense of replacing batteries and starter motors. Secondly, in congested areas, the frequent engine start-stop cycles create vibrations that can be uncomfortable for passengers. Thirdly, when the engine is turned off, the air conditioner ceases to function. The air conditioner compressor relies on engine power, so when the engine stops, the compressor also stops running. This lack of air conditioning can make the car feel like a sauna during hot summers. Given these disadvantages, many experienced drivers immediately disable the automatic start-stop feature when they start the car, often paying attention to fastening their seat belts as well. Despite its unpopularity among drivers, more and more car companies continue to incorporate automatic start-stop systems. In summer, the cooling effect of an air conditioner is definitely the most important indicator of a car's quality. Do you know how the refrigeration system of a car air conditioner works? Thank you for the little red heart, and let's understand the refrigeration principle of the car air conditioner in 1 minute. You may have seen outdoor cooling systems that spray water. The water is atomized under high pressure and evaporates quickly in high temperature or normal temperature environments. During evaporation, it absorbs heat from the surrounding air, making the environment cooler. Car air conditioning works on a similar principle. The refrigerant in the system is atomized and absorbs heat during evaporation, lowering the temperature of the air and sending cool air into the car. When you turn on the car air conditioner, an electronic clutch drives the compressor to work. Since the compressor is powered by the engine, turning on the air conditioner increases fuel consumption. The compressor compresses the refrigerant into a high-temperature, high-pressure gaseous state. The gaseous refrigerant then enters the condenser at the front of the car through a pipeline. The condenser and fan cool down the refrigerant. The refrigerant condenses into a high-pressure, low-temperature liquid as it releases heat. At this stage, a dryer in the condenser absorbs moisture and impurities from the refrigerant to prevent water blockage, ice blockage, and dirt blockage in the pipeline. The high-pressure, low-temperature liquid refrigerant that has completed condensation passes through an expansion valve. The expansion valve acts as a nozzle that sprays the refrigerant into the evaporator. Here, it is depressurized and becomes a low-temperature physical state. It evaporates in the evaporator and absorbs heat. Fresh air cools down as it passes through the evaporator before being sent into the car. The refrigerant, after absorbing heat and evaporating, becomes a room temperature, low-pressure gas and re-enters the compressor. At this point, the car air conditioner completes one refrigeration cycle. As long as you don't turn off the air conditioner, this cycle will continue. Isn't it simple? In our next video, we'll discuss why an air conditioner might stop cooling or why its cooling effect might deteriorate. If you don't want to go to a repair shop, how should you handle it yourself? If your car's air conditioner isn't cooling, how will you get through the summer? In fact, there are only a few reasons for poor air conditioning performance, and they can often be solved for just a few dozen dollars. Firstly, if the air conditioner doesn't cool at all, check whether the clutch suction cup of the air conditioner compressor is rotating. If there's no frost on the air conditioner pipe, it can't drive the compressor to work. This situation generally indicates a pipe rupture or a leak at the pipe interface. Secondly, if there is some cooling, but it's not effective, after turning on the air conditioner in the car, locate the low-pressure and high-pressure pipes in the cabin. The thicker one is the low-pressure pipe, and the thinner one is the high-pressure pipe. The high-pressure pipe should be at room temperature under normal circumstances. If it feels hot, it indicates that the air conditioner has a poor heat dissipation effect. You'll need to check the condenser at the front water tank position. Usually this issue is caused by an excessive buildup of dust layers, mosquitoes, and catkins on the condenser. You can go to a repair shop to have the front bumper removed and clean it properly. Washing from the front of the car usually doesn't clean it thoroughly. Now, let's talk about the low-pressure pipe. The low-pressure pipe should normally feel cold. If you touch it and find it's not cold enough, it means there is a lack of refrigerant. A repair shop can add more refrigerant for you. If the low-pressure pipe is cold but the car interior isn't cool and the airflow at the air inlet is very weak, then the air conditioning filter may be too dirty and clogged with debris. In this case, you need to replace the air conditioning filter. If it's that dirty, then it's likely that the air filter isn't much better. Replace them both. Your air conditioning will be cooler and free from any sour smell. Isn't it simple? Whether a car's chassis is high-end or not depends on the suspension. Luxury car brands such as BMW, Audi, and Porsche all use the McPherson suspension, which is perceived as cheaper. Why is this? In fact, the McPherson suspension they use is not the traditional type, but a variant known as the double ball joint suspension. The original triangular arm of the McPherson suspension is modified into two connecting rods. These rods can independently handle the lateral and longitudinal movements of the vehicle, which somewhat improves the suspension's performance, maintains the space-saving characteristics of the McPherson suspension, and enhances some aspects of its performance. However, compared with the double wishbone suspension, it cannot match the performance of a double wishbone without an upper wishbone. The control force of one hand grasping something is not as strong as that of two hands. The double wishbone is also not superior to multi-link. So why do luxury car brands still use McPherson suspension? Firstly, for a family car, a well-tuned McPherson double ball joint suspension can already meet all driving scenarios. You can't turn your family car into a racing car. Secondly, although double wishbone and multi-link suspensions are not much more expensive to produce, they are more challenging to tune. The McPherson suspension has a simple structure and is relatively easier to tune, while double wishbone and multi-link suspensions are very complicated to adjust. Although some cars have double wishbones, their driving experience is often not as good as that with McPherson suspension. We can think of the structure of the suspension as a move. The manufacturer's tuning of the suspension is akin to internal strength. Having moves but no internal strength is just for show. It looks good but isn't practical. Multi-link suspension is a prime example. It's based on similar principles and ideas. The same 5-link can provide different experiences in different models. In this case, the advantage of using a double ball joint suspension becomes apparent. Using a double wishbone suspension may not yield good results despite considerable effort. Cheap and easy to use, it doesn't take up much space. Double ball joints that are easy to tune and worry-free naturally become the first choice. If an experienced driver is racing on the road and suddenly encounters a large rock, the driver might have a close call. However, with a seat belt, the situation seems different. The earliest seat belts were secured with springs, which could be extended with minimal force, and this seemed adequate. Yet, this design could not restrain the driver in the event of an accident, proving to be aesthetically pleasing but impractical. Engineers designed a steel ball device to address this issue and added a sprocket on one side of the reel. The sprocket normally rotates freely, but in the event of a collision, it moves forward due to inertia, simultaneously activating the locking mechanism to secure the sprocket firmly. However, another problem arises. If the seatbelt is too tight, it can exert significant pressure on the driver's chest, potentially leading to strangulation. To mitigate these issues, engineers introduced an additional component, particularly an orange part, that rotates in tandem with the central part during slow rotation. When the vehicle abruptly stops after an accident, the orange part lags, triggering the locking device. This innovation did not fully resolve the issue until the introduction of the torsion bar, which revolutionized the system. The left end of the torsion bar is fixed. allowing the right side to rotate freely when locked, thus providing a cushion for the body. Along with airbag support, this significantly enhances the driver's chances of survival. Some luxury cars are even fitted with explosive seat belts. Typically, drivers apply the brakes before a collision. Should the system sense an impending accident, the explosive device within the piston mechanism ignites, propelling the piston and instantly tightening the seat belt to minimize the impact of the collision. This fire truck, worth tens of millions, is truly amazing. Although it is large, it has no wasted space. The left side serves as a mobile arsenal, equipped not only with electric saws that can cut through iron as if it were mud, but also with fire axes, fire hammers, and more. Oxygen tanks and dry powder fire extinguishers are also essential. On the other side, there are foam and carbon dioxide fire extinguishers, along with other firefighting tools, and the space at the top is fully utilized. Various types of hoses and fire ladders are stored here, and there are two hard pipes on the side for directly pumping water from a pond in special circumstances. The pump, which is the heart of the fire truck, is located in the center and is powered by a diesel engine. Its formidable power allows it to pump 200 liters of water per second. The water tank, situated at the rear of the fire truck, is divided into 4 smaller tanks with a combined capacity of 4 tons. Using the fixed ultra-high-pressure water gun mounted on top, the water supply will be completely exhausted in approximately 1 to 3 minutes. The cab's interior space is also very spacious, comfortably accommodating more than 5 people. There is a helmet hook above, as well as plenty of other equipment. So, do you know why fire trucks around the world are red? The inventor of the car door lock is truly talented. Are you curious about how your car door unlocks? Pay attention. When you open the door of the Hongguang 50, you will see a lock hook on the door frame. If you take a closer look, you will notice an iron ring. Now look at the door on the other side. There is a lock buckle hidden inside. When you close the door, how does the lock buckle lock the car? Use your 82-year-old hands to quietly disassemble the lock buckle. Be careful not to break it, or you might get scolded by your spouse. Inside, you can see its internal structure. There is a gear on each side, and both are mounted on a torsion spring. Between the 2 gears, there is a locking plate installed. The bottom of the locking plate is connected to a spring. You can stretch this spring and adjust the angle of the locking plate. When the door is closed, the lock hook contacts one of the gears, causing it to rotate. Then the locking plate secures the gear, preventing it from rotating backward. As the gear rotates, it is clamped by the torsion spring, locking the car door tightly. When we want to open the car door, we pull the handle inside, which is connected to the locking plate. The locking plate rotates under the action of its spring, and because of the preload from the torsion spring, the gear automatically returns to its original position, releasing the lock buckle from the lock hook, allowing the door to be opened. The function of the gearbox is not only to accelerate and decelerate, it also adjusts the torque of the car while changing speed. Before we delve into this topic, let's understand what torque is. Imagine 2 wrenches. One is 10 centimeters long, and the other is 5 centimeters long. Both wrenches are used to turn a screw simultaneously. It's evident that the longer wrench requires less effort because its lever arm is greater. Torque can be thought of as the twisting force applied by the wrench to turn the screw. The 10 centimeters long wrench has greater torque, while the 5 centimeters wrench has less torque. However, the shorter wrench can turn the screw faster. Why? Because it covers a smaller circular distance, resulting in higher rotational speed. Now consider the same force acting on both the 10 centimeters and 5 centimeters wrenches. The 10 centimeters wrench can easily unscrew the screw. The 5 centimeters wrench can unscrew the screw more quickly. This analogy applies to a car's gearbox as well. When starting or driving uphill, more force is required. Therefore, the gearbox shifts to the first gear, which provides high torque but slow speed. On flat roads, excessive force isn't necessary, but speed matters. In such cases, the gearbox switches to higher gears, for example, 5th gear, which offer lower torque but faster speed. The gearbox design relies on a combination of gears of varying sizes to achieve the desired torque and speed changes. When the larger gear drives the smaller gear, the engine flywheel's speed is slower than that of the wheels, resulting in fast vehicle speed with low torque. Conversely, when the smaller gear drives the larger gear, The engine speed exceeds the wheel speed, leading to slower vehicle speed but higher torque. In summary, gearbox shifts involve adjusting gear combinations to optimize torque and speed for different driving conditions. Is this explanation clear? Feel free to like and follow for more. The person who invented the vacuum tire is an absolute genius. It ensures that the vehicle can maintain stable driving even if a nail pierces it. In contrast, once a nail pierces an ordinary tire, it is easy to lose control, which may even cause a traffic accident, resulting in the tragedy of car destruction and death. Let's first understand the structure of an ordinary tire. An ordinary tire consists of two parts, the rim and the rubber tire. If it is directly inflated, the gas will easily leak, so an inner tube must be installed inside. However, after this inner tube is inflated, if the tire is punctured by a nail or another object, the gas in the inner tube will quickly leak out. The tire opening will also be quickly torn, and even a tire explosion may occur, causing the vehicle to tilt and lose balance and control. This is very likely to cause a traffic accident, resulting in car destruction and death. However, the advent of vacuum tires has completely changed this situation. If an ordinary tire is compared to a balloon, when it is punctured by a needle, the balloon will burst instantly. In contrast, a vacuum tire is like a layer of tape on the balloon. When it is punctured, the opening will not tear because of the tape. To make this design more perfect, the designer integrated the inner tube and the rubber tire into one, specially designed the wheel rim, and then installed a sealer nozzle inside. Thus, the vacuum tire was born. I don't know how many lives it has saved. Like and follow.
The person who invented the electric bike is definitely a genius. The electric bike is driven by a powerful motor and uses a lithium battery as the energy source. The DC power of the battery is converted into the AC power required by the motor through an inverter, which is connected to the controller. If you are carrying a 10-year-old child at this time and are still on an uphill road, as long as you press the accelerator, the controller will command the inverter to increase the output power so that you can successfully complete the uphill operation. Now put this set of things into the electric bike. After starting the electric bike, the motor will drive the rear wheels to rotate through transmission methods such as chains or belts. The strong power can allow experienced riders to travel on the road at a speed of 25 kilometers per hour. The electric bike even has a powerful BlackTech shock absorber spring. The shock absorbing spring connects the frame and the triangle bar, and the triangle bar can rotate around this fulcrum. When the wheel encounters a bumpy road section, the impact force received will be transmitted to the shock absorber spring. It is precisely because of such high-end configuration that the electric bike is as stable as an old dog. There is even a storage box hidden under the seat, which really makes the best use of everything. Additionally, there is a standard braking function, and the bike will stop with just a pinch. Like, comment, share, and follow.
The airbag is truly ingenious. It inflates rapidly, enveloping your face within moments. Did you know that the inflation of an airbag involves a chemical explosion? A small iron ball plays a crucial role in this process. During normal driving, the iron ball adheres tightly to an ultra-strong magnet. However, when the vehicle collides, inertia causes the iron ball to separate from the magnet, propelling it forward. This movement completes a contact circuit, acting as a switch. The circuit connects to a heating wire installed at one end, which is placed within the chemical explosive. Modern airbags typically use sodium azide as the chemical explosive. When exposed to high temperatures, sodium azide rapidly reacts, producing a substantial amount of nitrogen gas. Remarkably, just 50 grams of sodium azide can generate 70 liters of nitrogen. When the circuit connects to the heating wire and the temperature exceeds 300 degrees Celsius, the sodium azide detonates, filling the airbag in a mere 30 milliseconds and maintaining full inflation within 100 milliseconds. In the event of a significant impact, the airbag may deploy. Fortunately, today's airbags are intelligent. They analyze sensor data, including acquisition speed, gyroscopes, and other inputs, to determine precisely when to trigger, so there's no need to worry about accidental airbag deployment. When the airbag inflates and propels outward, it can reach speeds of up to 100 meters per second. Remember to fasten your seatbelt, otherwise the airbag's force could be lethal. Many people say that the torque of a car determines its acceleration and load capacity. Is this true? What is the torque of a car? What determines the size of the torque? If you are also curious about these questions, you must watch this video today. It explains in detail how the torque of a car is generated and what effects it has on the performance of the car. Before that, we need to understand what torque is. Torque is actually the force that twists an object. For example, if we use a 5-centimeter wrench to tighten a screw, we regard the twisting force at this time as 1. If we use a 10-centimeter wrench to tighten the screw, will it be easier? Is the twisting force amplified? So as long as the wrench is longer, the torque will be greater. Torque also represents rotational force. If the torque is applied to the car, because the wheels are round, to make the car move, the wheels must rotate. The force that makes the wheels rotate can also be regarded as torque. If a car is full of goods and you are asked to push it, but you can't, then you can only call someone to help increase the torque of the wheel, or drop some goods to reduce the load. Therefore, the torque of the car determines the load capacity of the vehicle. The torque on the car refers to the torque from the crankshaft output end of the engine without passing through the gearbox. The torque of the engine is just like screwing a screw. The longer the rocker arm on the crankshaft is, the greater the torque generated by the engine. Therefore, the torque of the car is actually determined by the length of the force arm on the crankshaft. The longer the force arm, the greater the torque. The faster the starting advantage, the faster the acceleration. If two bicycles accelerate from 0 to 40 yards, one with a large wheel and one with a small wheel, if the pedal speed is the same, the bicycle with the large wheel will accelerate to 40 yards in a shorter time. If the two wheels are the same size, the bicycle with a faster pedal speed will accelerate to 40 yards in a shorter time. The same is true for cars. With the same torque, the faster the speed, the faster the start. With the same speed, the greater the torque, the faster the start. It's like a diesel car and a gasoline car. The peak speed of a diesel engine does not exceed 4,000 RPM, while the peak speed of a gasoline engine can reach 7,000 RPM. Although diesel cars have more torque than gasoline cars still accelerate faster. However, if they are both household gasoline cars, it is not wrong to say that the greater the torque, the faster the start. After all, you are not driving a racing car that can run at 20,000 RPM. Anyway, everyone's speed is about the same, so naturally, the greater the torque, the faster the start. Is it very easy to understand? There is a very important process in the manufacturing of tires. This is the vulcanization process. In simple terms, vulcanization is the transformation of rubber. Imagine that rubber is originally like a soft piece of plasticine that is a little sticky. It is not strong and not easy to use. Through the vulcanization process, it becomes hard and elastic. It is also very wear-resistant. Rubber undergoes a transformation, becoming both strong and durable. Doesn't it feel like making pasta? After adding baking powder, the dough becomes fluffy and elastic. The taste is also stronger. Early vulcanization involved adding sulfur to rubber. Now, there are more things that can be added, such as vulcanizers, accelerators, surfactants, etc. So now the term vulcanization has gradually evolved into a general term for the reaction of various chemicals with rubber. In the vulcanization process, the vulcanizer is like a matchmaker for the rubber molecules, allowing them to hold hands, shoulder to shoulder, tightly combined. Like building a series of solid bridges connected to form a dense three-dimensional network structure. In this way, rubber becomes particularly elastic. At the same time, its hardness and tensile strength are greatly enhanced. The vulcanizer plays an important role in the whole process. That is to say, in addition to the familiar sulfur resin and metal vulcanizers are also commonly used. Vulcanizers are added during rubber refining, rather than added in the later vulcanization process. Which vulcanizer to choose? It depends on the type and use of rubber. For example, tires and soles. The added substances are definitely different. The most suitable vulcanizer will be selected according to the specific situation, ensuring that the rubber products can achieve the best effect. There are many specific vulcanization methods. Common ones include hot vulcanization and cold vulcanization. Hot vulcanization is a more traditional and widely used method. The vulcanization reaction is achieved by heating the mixture of rubber and vulcanizer. Cold vulcanization is the vulcanization of rubber products at room temperature, such as the bonding of rubber to metal, rubber to fabric. It has the advantage of relatively simple operation in some specific cases. Like and follow for more informative videos. If these 8 lights come on while driving, you must stop and check immediately. Saving your life is the most important thing. As long as you maintain your vehicle regularly, the probability of a fault light on your vehicle is very small. However, if it does come on one day, you will know what fault it represents. First, the engine fault light. Engine faults can be big or small. A big fault may be a broken component, and a small fault may be due to low fuel quality. But you won't know the problem until you check it, so stop and check it first to find out the cause. Second, the ABS anti-lock braking system, ABS fault light. If there is no ABS intervention during emergency braking on slippery roads, it is very easy to cause rollover and lose control. Third, the brake fault light. There's no need to say more about the role of the brake. It's not an exaggeration to call it the most important control device in the car. Fourth, the cooling system fault light. If the engine cooling system fails or the coolant temperature is too high and the coolant leaks out, it only takes 20 minutes to damage the engine or render it unusable. Fifth, the battery fault light. This usually indicates that the engine is broken or the generator belt is damaged. Moreover, it will also cause the power steering pump to stop working. Sixth, the oil fault light. The function of engine oil is to lubricate the internal parts of the engine. If the engine's lubrication system fails, it will also cause the engine components to wear out within 20 minutes, potentially leading to engine failure. Seventh, the power steering system fault light. Generally, when this fault light is on, it will also be accompanied by problems such as heavy steering, abnormal noise, shaking, and lack of steering responsiveness. Eighth, the tire pressure warning light, which indicates that the tire is leaking and the tire pressure is too low. Approximately 90% of high-speed tire blowouts are caused by low tire pressure. Remember that the tolerance for driving is 0%, so when these fault lights come on, don't ignore them. Even seemingly minor faults can have serious consequences. We all know that AT gearboxes are durable and have a low failure rate. But why do more and more car companies not use them, but use dual-clutch gearboxes and CVT gearboxes instead? In fact, this question is still quite complicated. Let's analyze them one by one. First, most of the patents for AT gearboxes are in the hands of Japan's Aisin and Germany's ZF Friedrichshafen. Other car companies cannot avoid patents if they want to produce them, so the supply of AT gearboxes is insufficient, and they have to use other gearboxes. Second, the fuel consumption of AT gearboxes is relatively high. It transmits power through a hydraulic torque converter. When driving in the city or starting at a low speed, this flexible connection will cause a large power loss during power transmission, and the transmission efficiency is less than 80%, which affects fuel economy. In contrast, DCT uses a rigid connection such as a clutch in its design, which has less power loss and higher energy efficiency. Because CVT has no mechanical gears, it can always keep the engine running efficiently. It can also reduce the energy loss of the engine, achieve the purpose of fuel saving. Third, AT gearboxes are more expensive. Because of their complex structure, the manufacturing cost is 1 to 2 times higher than DCT and CVT, especially the high-end 8AT and 9AT. The cost can be directly doubled. So using DCT and CVT can better control the cost of the whole vehicle, especially now that the market competition is fierce, when the price is relatively low. Fourth, DCT and CVT are better than AT gearboxes in terms of smoothness when shifting gears. DCT can provide fast shifting capabilities similar to manual gearboxes. CVT shifts more smoothly. Both can provide a driving experience different from AT gearboxes. Of course, AT gearboxes are not eliminated. In some luxury brands and large SUVs, especially those models that are durable, AT gearboxes will still be used because they not only have a low failure rate, but also can better handle large torque output. This is also an advantage that other gearboxes cannot replace.
Do you even know why we call a diesel engine a diesel? In the late 19th century, German engineer Rudolf Diesel gave himself a mission, creating an engine that would surpass the efficiency of steam engines, the dominant technology at the time, and so was born the diesel engine. In 1893, Rudolf Diesel came up with his first prototype but faced countless challenges, including issues with fuel injection as well as difficulties achieving the necessary compression. But things were about to get better. After spending 5 years refining his design, Diesel built in 1897 his first successful prototype running on peanut oil, showing a much higher efficiency than the contemporary steam engines. This would change the world forever. Completely transforming industries, Diesel's invention was soon adopted for various applications including marine propulsion, power generation, and eventually transportation and agriculture. But in 1913, Rudolf Diesel disappeared under mysterious circumstances while traveling to England.
Is the world's longest mileage car, having covered a total of 5.23 million kilometers over 52 years. This distance is enough to circle the Earth 130 times or make 6 round trips to the moon. It is regarded as a marvel in automotive history. In 1966, an American man named Gordon purchased this Volvo 1800S for $450. He was passionate about cars, driving 160 kilometers to school every day, and also using it for road trips during holidays. As a reward for surpassing 4 million kilometers in mileage in 2009, Volvo specially gifted him a brand new sports car. However, Gordon seemed uninterested in the new car. Until his death in 2018, the car had been by his side for 52 years, accumulating an astonishing total mileage of 5.23 million kilometers. Throughout Gordon's driving career, the Volvo consumed over 400,000 liters of gasoline, 3,180 liters of oil, underwent 3 water pumps, 5 generators, 6 sets of shock absorbers, 156 tires, 464 spark plugs, and received maintenance 829 times. Surprisingly, the engine had no issues and could still run normally. It has since been collected by Volvo